class, because if we can't focus and get through class, then that is the thing that can be sacrificed and like not happen today. Yeah, this didn't happen. I like to leave my slide from the previous day because whatever class is leading, it's kind of my way to check. And guys, you can't have that window all the way open. Like, I can see it snowing inside. You can have it kind of open, like, but there are other people in this classroom. Was it just like, how far can we open this? Like, I get it, but there are other people in this room that may not like the 20-degree air. Yeah. Well, put your coat on if you want. I can't tell them not to open the window, especially during COVID times, but yeah, just, be considerate. If you get too cold, obviously put on your coat, but then for real, speak up if it's too cold. Like, when my hands get cold, I can't write, so speak up if it's too cold. We'll shut the window, but I'll let those guys let some fresh air in here. I did not really catch up on grading Sunday, so I need to try to do it tonight. I had a couple weekend tasks that I was just trying to get wrapped up, and I did by like 9:30 last night. I was just finishing stuff up, so I did not get my grading done. If your math notebook is missing, please don't put it in the cubby. You need to come show it to me. It's real fast. Just come show it to me. That's it. Khan Academy, we're doing blue versus green, so when we check it today, it is you guys versus tomorrow's guys. All right, so this is where we left off last week, talking about word problems that result in a system of equation situation. Can anyone remind us what makes these situations tricky with like how we set these up? Also, because I can't remember exactly how far your class made it or not. Okay, but what made it tricky? We had like a then and a now. So the problem that we ended on, if we want to jog our memories, was this one. Right, so this should be like the last thing you had written in your notes, guys. Like, if you want to check, you should have a K and a D situation. So we had that Kevin is 3 years older than Daniel. 2 years ago, Kevin was 4 times as old as Daniel. Now, if any of you guys have started these in Khan Academy, you'll be able to probably remember, oh yeah, this gets tricky because... And sometimes one of my green kids was kind of like, hey, why are you working so hard? Can't you just like think about it and figure it out? And it's funny because this is where I'm like, yeah, you're smarter than me. Like, no, I can't just think and figure it out. This student, one of your green classmates, could literally, like, in these situations, just like, okay, it's got to be this. And they solved the system in their head just through, like, reasoning. And that works right now for, like, age situations. Some people can do that. But, guys, what we're setting up is the skill set for when that won't work, right? When reasoning through in your head can't. Like, it's too complicated. Like, we're talking about, like, gravity and air resistance and, like, crazy things like that. Audrey? Yep. That's how my brain works too. Yeah, it's gone. I have graph paper all over the place to the point that one day when my wife was walking around the house and she's like, the one day I need paper and I can't find it. Like, Micah, where is the paper? I was like, yeah, I cleaned. Like, because I normally have graph paper, like, in the kitchen, in the office, in the bedroom, in the, like, wherever I've been writing things down. And yes, I've got part of my wall in my bedroom removed right now to get to plumbing. I'm always in the middle of, like, 8 projects. But there's graph paper anywhere that I am writing things down. So, here's what made this tough, because I'm afraid we're about to, like, spend too much time just chatting. We have to think about the then and the now, right? The thing that snagged us last week with talking about Kevin and Daniel was the then versus the now. So we're going to set up, sorry, please head your paper with systems word problems. So I'm trying to rip all my old notes out of here because I did not on Friday or on Thursday when I should have. Systems word problems. Now what this tells us, and I was told that that's Ishan, is how you say that, is Ben is 4 times older than Ishan. Sorry, as old. Let's be particular with how we say these things. 4 times as old and 4 times older than is actually technically different. Most people use it the same. We Americans are really bad at saying things mathematically in a way that we don't follow. So 4 times as old as means like my age is 4 times yours. 4 times older than would actually mean add on that 4 to, like, it's technically different. We normally don't do that, right? But that's why this says 4 times as old as. That is the correct way to say it. So when we go to set up that system, what we get is Ben is 4 times the age of Ishan, right? Ben is 4 times the age of Ishan. But then they say and. Okay, another equals, right? Like and is another equals. 6 years older. Okay, good. So there's no time travel happening here. This is all right now. Because I realized that the problems where we think about then and now were a tad bit too difficult and we needed to step back for a moment. So all of this is right now in the present. Ben is 4 times as old as Ishan and 6 years older than Ishan. So maybe Ben is babysitting for Ishan. Who knows? Let's figure this out and then we'll see, is that reasonable that Ben is babysitting or not? So if we set this up algebraically, we can go 2 different routes. So, remember, I don't just want the answer. Anytime you raise your hand and say, I got the answer, like, I'd rather, like, I know how to solve it. So, what could we do? Do you want to tell me what we did to get here? What did you do? Or did you just think it out and solve it like the student I was talking about? You just, like, thought it out and solved it? So, because you can like plug things in and try it. Yeah. So Dewan's doing what I'm talking. I'll tell you guys. It was Adam Chapman was saying like I can just think it out, and I was like, your brain sounds sweet, but I can't. Like it was one of those like it's okay that you're smarter than me, but you don't have to keep flexing about it. Like, so if we algebraically, guys, this, and I'll admit every now and then something like this scares me, and I forget. Oh yeah. Subtract an I from both sides. 4i, I can subtract an I from that. So I can get 3i equals 6. Or somebody in the yesterday class, sorry, I keep trying to say morning class, somebody in the green class said, couldn't I set up that Ishan is Ben's age minus 6? And I said, yeah, but is that really useful here? Not really. Yeah, like, because we already have an I equation, like, set up with just I's, why bring the B's back in? We don't want 2 variables. We just want 1 variable. So when we solve that, we get that Ishan is 2. Now, I don't think it makes sense that Ben is babysitting Ishan, because if Ishan is 2, how old is Ben? 8, and he probably should not be babysitting. Right? That's probably not, we shouldn't do that. Don't trust the 8-year-old with the 2-year-old. I need an adult, please. I need an adult. All right, so try this one on your own. So I made it bigger. Juan, you can walk outside the building, go around the building, and just peek your head in and just follow class from... I'm joking!
He's gonna go outside.
And what I said was you had to walk around. I didn't say climb out. Mr. Flynn shows up and there's just the top half of DeJuan sticking out the window. Just see feet. You know what you need then is butter. If you're stuck, sorry, my dad always said, not my dad, my father-in-law always says, if it's stuck, you need butter. You put butter on stuff? He's like, yeah, it's great. Yeah, he seriously is like, oh, you got a squeaky hinge? Put some butter on that. You just put butter on everything? Michael is 4 times Brandon's age. Michael is 4 times Brandon's age. And not a mathematical like addition and, but also is 27 years older than Brandon. Luckily, I'm not 27 years older than you guys yet. I'm marching my way to get there, though. Right. Your statement is correct. What I mean is 27 years older than a 7th grader. Not necessarily you, but I appreciate that you caught up on my mathematical inaccuracy of I will always be about 20 years older than you. Because I'm 32. April. So, okay, I'm 32 in April. I'm 31 right now, but I'm like, I'm closer to 32 than I am.
I'm about 13 in a month from Saturday.
Yeah. So if you guys are 12, which a lot of you are 13 now, but if you're 12 and I'm almost 30, I'm about 20 years older than you guys right now. All right, so what do we do on both sides? Subtract a b. So then we have 3b equals 27, which means Brandon is 9. Yeah, so Michael could babysit Brandon. We would probably trust Michael. Because how old is Michael? 36. If you can't trust Michael... Yep. I'm almost there. I'm almost there. Alright, I'm going to pop my notes back up. Hey, don't freak out at me. I'm going to pop my notes back up. But here's your new problem to solve. Sorry, it's all pixel. Slow-mo guys, or whatever they're called, have a new video about, well, actually, I don't know if it's new, but about how a TV works, like the pixels of a TV. It is fascinating. If you've never learned about how a pixel actually works, yeah, I would say if we have if we have time at the end of class, I'll show you that video. The first thing you should do is separate the problem into at least just the first equation that you want. So the first part, Ben is 20 years older than Daniel. Ben is, B equals. Right? B equals, Ben is. 20 years older, Ben is older, so D plus 20. Right? Because Ben needs to be the older age. That's equation 1. That's it. Nothing else from the first sentence matters now. Right? So now we're moving on to equation 2. Ben and Daniel first met 2 years ago. Take that sentence, crumple it up, and throw it in the basket. It's garbage. It's useless. It's Pointless, except for, oh, your friendship is 2 years old. It doesn't matter mathematically when they met. Yeah, they could be arch enemies. Who cares? What we care about is the next sentence, 3 years ago. How would we represent 3 years ago? Oh, -3. Ben was 3 times as old as Daniel. So when we talk about B and D, now we're talking about B minus 3 and D minus 3. So our two equations are this. Double check that those are your two equations and solve those. Anyone think they got it? I mumble. Go back then. Go see what you can do right, Zoe. What do you think? Do you have B or D? You have both. What do you think? That is not correct. Check your distribution. If we have B minus 3 equals 3D minus 9, what could we do on both sides? B's already closer to being alone. So if we add 3, sounds like a good suggestion, we get -6. Here's your first trap door. If you have -12, you accidentally subtracted 3. Then we keep going. But now that we have B equals, right, because we've been able to just get to B equals, this side is the other B equals. So again, guys, this is the first thing I taught you, equal values method. As soon as two things are equal to the same thing, they're equal to each other. Thoughts? Okay, so let's zoom out before we take more contribution. The problem told us Ben is 20 years older than Daniel. So are you cool with how I wrote B is equal to D plus 20? That, why I highlighted that in green, is that should be the one that's easier to write. That equation's easier, right? Not easy, but easier. Then 3 years ago, Ben would be 3 years younger and Daniel would be 3 years younger. So one thing you could do, if this helps, is, hang on, just put it down for a second, is you could say little b and little d. I'll just watch. 3 years ago, Ben was, so little b equals 3 times as old as Daniel. 3 times little d. Right? So if I use small, like younger Ben and younger Daniel, does that make sense? But now, younger Ben was big Ben minus 3. Right? Younger Daniel was big Daniel minus 3, but that 3 times will have to go to each piece here. So that's how it ends up written like this, and how it distributes to be written like this. Are you with me for how we get to b minus 3 equals 3d minus 9? So now we try to just purely do algebra. So like kind of turn your brain down a couple clicks and just try to go back to like what rules can I follow, which I hate saying that, but we're not being creative here. We're just following rules. So I can add or subtract, multiply or divide anything I want as long as I do it to both sides. Easier way to start is add 3, because that would isolate the b. So where I think I confused you was that gets us to, I need more blockades. That gets us to here. Are you cool with how we got to b equals 3d minus 6? Then I'm like, oh, b equals, I got a b equals there and a b equals there, and they're two different b's, so equal values method, boom. Now here's why we did that. B and D are two different variables. I can't solve with two different variables. I can do stuff, I can do algebra, but I can't ever solve while I still have two variables. I need just one variable to actually be able to and solve, right? So that's why we say b equals what, and then we solve it. Does that make sense? A bit more of why we've done what we've done. Now the what we actually do to solve this is anything we want. I could subtract 20, I could subtract d, I could add 6, I could subtract 3d. I could divide by 3, that would get a bit tricky. So and maybe I should not have done this, I did two things at once. I subtracted d from both sides. And I wrote down 2d, and then I was like, well, wait, at the same time, I could also add 6. So if you're really careful, you can do algebra steps at the same time. Otherwise, do one step, then do the next step. Daniel ends up being 13. Which means Ben is 33. Does this, who's got questions about that is really what I should say. My friend's brother Daniel, from back when we were kids, I don't know if I trust him. Try this on your own. It's less blurry. Hopefully it's a tad easier. I emailed them and asked them if they would use names like Logan, and they said he talks too much during class. Logan would have seen that, but he was talking. The equations that we should have. Now, there's always other options. Like, I've got an alternative option written up here. But if we just take purely what they told us, something like that. Question?
Is it okay for that I did I equals C plus 20? Oh, okay.
So there are always multiple options of how we can write this. Zoe? Does it matter what? Yes, it does matter. You have to ask yourself, who is older? Right? So when it says 14 years ago, Eshan was 3 times as old, that means the other side gets the multiplication by 3. Because so again, think back to like little I. If we set up an equation using like the little i's, little I was 3 times as old as little c. Right? If I use little I, little c, then I replace this with I minus 14, c minus 14. It does matter which side the 3 goes on. Do we think we got it? If we start working it, we distribute. But, I forget who asked, is it okay that I wrote I equals C plus 20? That's brilliant, because that can be used for us. Right? So when we get 3C minus 42 equals I minus 14, we can plug in that I is actually C plus 20. Right? Because remember, we have 2 different equations. This equation is this equation. But this equation is its separate equation, right? So we're allowed to plug in one equation to the other equation. So this was, quote unquote, our second equation they gave to us. Still second equation they gave to us. And we plug in the first equation they gave to us for that I. We then could have subtracted I. I realized, oh wait, that's a bad idea because I'm going to substitute I instead. So when I thought about subtracting I was like, wait, I can't do that on both sides. That seems like a bad idea. So 3C minus 42 becomes, I might as well highlight this. I replaced my I with my C plus 20. And I still have my minus 14. Questions about how I got to this point? I know, that's why we're practicing these together. Yeah? Sure, if it worked out. We'll see. I will see. C should be 24, I should be 44. Please ask questions if that doesn't make sense to you. Please ask questions if that doesn't make sense to you. We went from up here. We added 14. I left this big gap. I don't know why. We added 14. That brought us down to here. I don't really know. I don't know what this is doing here. That doesn't need to be there. Yeah, I don't know what that was all about. I'm rather confused at why I wrote that there. Yeah, that happens. I don't know why, but... Oh, you just wrote it backwards. Yeah, I got you. Are you guys blue or green? There's a substantial difference between blue and green this week. Hey, it depends what color you are. Audrey. Whoa. Good work. Don't worry about it. Good work, Audrey. All right, let's do another one. Last one we're probably going to do today. And by that, I mean it is the last one we're going to do today. Because then we're going to do con kickoff. And I might show you guys the start of that video just to make you curious. This is also where we will continue working on Wednesday. If you decide these problems are too hard and you cannot get through the homework, please let me know. Send me questions. Send me even an email of like, hey, this is really hard. I would love it if you would extend due dates. Like, that's fine. But then I expect that you're coming to get help from me, right? Then I will normally respond, okay, when can we meet? I'm trying not to over-help. So I'm trying to give you guys some time to look at this on your own first. Here we have to be a bit more intuitive. Can anyone tell me what I mean by you have to be more intuitive? Go on. Can you guess what I'm going to say in response? What do you think I'm going to say? No, why would I say yes or no? That'd be too easy. What would go with I don't know? I don't know. Try it. So Dewan said, hey, so if I put that like 13 with that 5, can I just like divide by 18? Why? Why is he thinking about that? Zoe? Yeah, the plane has to be broken up into 18-seat increments. Because for every 13 economy seats, which are the cheaper what I fly, there are 5 business seats. I've barely ever even smelled business class, let alone ridden there. So that's because they're bigger and they take up more space. So there are 18 seats in every chunk. However, we're not all that intuitive to figure that out. So the first thing I would like us to be able to recognize in a situation like this is business seats plus economy seats. Total, how many seats in total did the problem tell us? 360. Ooh. So I'm gonna write this down. You said 360. So we're trying to think about this like a graph. And what we're saying is if E, like if things were like numbers, if we plug things in. So what we have to think about is what is E and what is B here, right? So over here, I had made B the number of business seats and E the number of economy seats. Here, 13E, this whole thing would actually be number of seats, right? And this whole thing would be number of seats. So I'm definitely not saying this does not work. Please do not think I'm saying this does not work. But what I'm saying is I can't use both of these at the same time. Because right here, I've said this is how many business seats and this is how many economy seats make the total amount of seats. This changes that. So I can't use variables in two different ways. So you have to decide how you're going to use the variables, and you should write that down. What does your B mean? What does your E mean? And if you're going to set this up, what does your B mean? And what does your E mean? I'm not so sure about that equation, so I'm going to bump back over to here where I feel safer. I'm not sure. This probably could work. I'm just not quite sure what B and E would be there. But all I know from the first sentence is a plane has a total of 360 seats. They're business and economy. For every 13 seats for 5 business seats equals 13 economy seats, right? 5 business. Audrey? Okay, we totally could. I agree. That's one way we can solve these things.
That's how I remember I got this question once before, and I immediately did a table.
Yeah.
I just immediately did a table.
Yeah. Do you have another thought? Shh, hang on. Hey guys, what you're saying is great, but stop talking over somebody else. Raise your hand and share it with the whole class. Unless you're not talking about math and just yelling at them about the window, and then we got to do some sort of like community vote thing. But we're being rude. We got math going on. Listen. Yeah, so what you guys tried, the whole 360 divided by 18, what'd that come out to be?
260 of the and 100
Yeah, so their route is your route. Their route said we have 18 seats in every like group of seats. And a group of seats is 13 economy and 5 business. So what your thought process really was, okay, if we have 13 and 5 in every group is 18. How many groups does this come out to be? 20. And then, well, if 20 is a group of business and economy, we can solve it. Like that 100% works. I do want to show you guys one there's a lot of ways to solve this. If you know 5 business seats equals 13 economy seats, I don't know exactly. Yeah, because I said B is business seats and E is economy seats, right? So 5 business seats equals 13 economy seats, wouldn't a business seat then equal 13/5 E? Because a business seat is worth more than an economy seat, right? So we could also do this and plug in, right? Because now I can do substitution. If I say 5 business seats is 13 economy seats, there's a lot of way to solve these situations. So that would become 18/5 E. I'm skipping steps. Sorry, because I know we're solving like in our own ways now. I need a calculator. 360 times the reciprocal. So E equals 100. Is that what you guys got? Did you guys get 100? Ah, B is 100. So I set this up backwards. Oh. Oh! Because, guys, we said, this is the trap door you're going to fall into, and I'm trying to expose it before you fall into it, but I have some people not paying attention. We said when B is 5 and when E is 13, these are equal. This is not true. We said, the problem said, when B is 5 and E is 13, I wrote a bad equation. This is not true. And nobody stopped me. Not 5B equals 13E, but 5E equals 13B. Why, you might say? Because the problem makes it look like the flip of that. Because when economy seats, are 13, and when business seats is 5, these are now equal. So the trap you are gonna fall into, and I hope you prove me wrong. Dewan, shut the window all the way, because you're not paying attention to what I'm doing. You're just acting like a dog in the car. Come on. Shut it all the way, lock it, come back to math class. You're exposing the issue with Windows. I'm trying to help you not fall into the trap door, and when you come to my classroom at Extensions and you're asking me about exactly this type of problem, I'm going to get frustrated because you were staring out the window instead of listening to what we're doing. This equation I wrote is bad, even though that's what the problem makes it look like. 5 business seats is 13 economy. That's not what I just wrote in the equation I crossed out. This is 5 times the number of business seats equals 13 times the number of economy. That's not true. 5 times the number of economy seats. There are going to be more economy seats, right? Will equal 13 times the number of business seats. Think about it like this. What does each one cost? Business seats cost more. Economy seats cost less. So we're going to fill up more economy seats, right? We put in more economy seats. Yeah, so then we got to scale it up. So we figured out there are 20 groupings. We can actually use this equation and solve it from there. This would actually give us that E is equal to 13/5 B. Right? The economy will be more than the business. Right? Always, like we talked about, always ask yourself, does this make sense? Should my economy class be equal? Should this fraction be proper or improper? Well, improper, because there's going to be more economy seats. And now, All right, and now, Math 8, February 1st. I'm just gonna let you guys keep asking who won. I can't zoom. There's my zoom. So, if you look, what I have done here is I have created 3 different tables down on the bottom, algorithms, if you're wondering how. So I have everyone plugged into this table. Then I delete all the blue people and make a green table. And I then go back to here, delete all the green people, make a blue table. Now, we all know that mathematical averages say how many people we have balances things out, right? Because you take your total, divide by how many. And I will say, Audrey Bratton, you are our, standout rock star for the week. So without even random selecting prize winners, go get a prize. You deserve a prize. Do you want me to tell them how much you did or no? Audrey did just over 1,000 minutes. Because she was kind of in hot water and a little bit behind and worked her butt off. So literally she made your class win. Well, divide that by 60. So it's over 10 hours. It's over an hour a day. It's probably 2 hours a day. A couple hours a day. So now I go, and we're blue, right? So in the spreadsheet, y'all are between the numbers 4 and 16. So I will go to random. And we do 4 to 16. Here's the problem, though. I look at your split of blue people, and you can only win if you are above the average of the class. And by what I mean by that is, did you help our class or did you hurt our class? Audrey obviously helped our class. That's why I told her to just walk up and get one. So for you to win right now, your number needs to come up and your average needs to be above 200 minutes. I know them because they're in the table right here. So generate a number. I look at number 14. That person did 16 minutes of work last week. Womp, womp. Sorry about it. You're not a winner. Number 13. That person did 120. Okay, this is not really fair because Audrey made the average so high. Let me recalculate this with Audrey out of here. I gotta remove Audrey to recalculate this and see.
Because otherwise none of us got that high.
Oh, guys. Without Audrey, woo, we're real close. Without Audrey. So we're looking for somebody above 149 minutes is what we're looking for. That's the average of your class without Audrey in it. Number 5. Nope. Number 8. Ivan Cooper, come on up and get a prize. All right, that is all the time we got for today. So this week there's just going to be one. I need to go buy more prizes too, so that's why this week we'll just do one prize winner. What? Oh, the banana's gone. It got taken this morning.
Yeah,
sorry. I realized I need to buy more fidget type things. So now, if you would like to forego your prize draw today and draw on another day, sure, but I can't guarantee anything better is going to show. You sure you don't want some stick-on tattoos? You don't want those? They're too girly for you? All right, guys, thank you so much for your hard work. Congratulations. Also, let's say this. I'll be a real nice guy. I don't know why. But let's just say I owe your class a piece of candy because you guys won. I owe all of you a piece of candy, okay? I don't have any right now, so I think I think I'm going to go buy a bucket of Jolly Ranchers. Hey, I'm coming around with lights. guys. I don't know why we're all leaving. I'm coming around. I know. I got you guys to stay seated. It's better. What up? You're welcome. These are super wet because we're at the bottom of the thing. So confused.
I don't know how to do it. I don't know how to do it either.
Do what?
Do Pokemon.